All right, welcome back. Today we're doing a real technical deep dive, a look under the hood at the absolute foundation of ShopSmart's MLOps system, their stage one data pipeline. And look, this is about way more than just shuffling data around. It's about building a bedrock of trust, reliability, and, most importantly, automation. Okay, let's get into it. So before a single line of this automated code was written, you gotta understand, ShopSmart was just drowning in data chaos. I mean, their whole process for trying to understand their customers was manual, painfully slow, and just incredibly fragile. This wasn't just a little inefficient, it was actively costing them big time.
Let's just start with one single painful number: 40 hours. Every single month. That's an entire work week gone, not spent finding cool new insights, but just wrestling with data.
Yeah, that whole time was spent manually exporting data, dumping it into spreadsheets, and just trying to make sense of it. And it wasn't just a time suck, it was totally reactive, right? You're always looking at old news. But here's the really scary part: it was filled with silent, costly errors. Think about it. One little copy-paste mistake could totally corrupt the data and poison any machine learning model you try to train later, and nobody would even know it happened. So, to fix all this, ShopSmart built an automated data pipeline. And honestly, this pipeline is the real hero of our story today. It's the system that turns all that chaos into control and makes sure that every single model is built on a foundation of clean, reliable, and up-to-date data. So, how does it actually work? Well, the data takes a pretty simple but really powerful four-step journey. First, we ingest it from all the different places it lives. Then, and this is critical, we validate it to make sure it's actually good quality. A tool called Perfect will then orchestrate the whole flow to run automatically. And finally, and you can't skip this part, we version the data. That way, we can reproduce anything, anytime. Let's kick things off with ingestion. This is all handled by a script they wrote called generateData.py. The cool thing is, the pipeline doesn't just look in one place. Nope. It pulls from their main PostgreSQL database to get all the customer and transaction history. Then it scrapes the application logs to see how people are actually behaving on the site. Session times, clicks, that kind of stuff. It even hits the Zendesk API to pull in customer support tickets. So what you get is a complete 360-degree view of every single customer. Okay, so how does this thing run on its own? Well, the whole process is orchestrated by a tool called Prefect. You can think of it like the conductor of an orchestra. It's the thing that kicks everything off every single day at 2 a.m. on the dot. And why 2 a.m.? Well, that's usually after all the source systems have been updated with yesterday's data, which means the pipeline is always working with the freshest data possible. Now, pulling in a bunch of data is one thing, but actually trusting it? That's a whole other ballgame. And that brings us to maybe the most important part of this whole system, the quality gatekeeper. This is their automated data validation, and it's powered by a great open source tool called Great Expectations. To put it simply, this thing is like an automated bouncer for your data. Before any data set is even allowed in the door to train a model, it has to pass a whole bunch of really tough checks. And let me be clear, this is not a nice to have. In any serious production-level MLOps pipeline, this is absolutely non-negotiable. So, inside their validateData.py script, ShopSmart set up 5 key checks that are tailored to their business. It basically asks a series of questions. Is the data complete? Does every single record have a customer ID? Is it accurate? Is the lifetime value greater than or equal to 0, because it can't be negative, right? Is it consistent? Is the last purchase date actually in the past and not some weird future date? Is it fresh? Did this data come from yesterday, or is it stale? And maybe most importantly, is every customer record unique? We can't be double counting people. And here is the most crucial part. What happens if even one of those checks fails? The pipeline doesn't just limp along with bad data. No way. It comes to a screeching halt. Everything stops, and an alert immediately goes out to the data engineering team. This is proactive gatekeeping at its best. And it prevents bad data from ever poisoning a model, which saves just countless hours of headaches down the line. Okay, so we've got the data, we've validated it, we know it's good. But what if we need to find this exact data set again in 6 months? How do we do that? Well, that brings us to the super important practice of data versioning, which ShopSmart does using a tool called DVC, which stands for Data Version Control. Look, if you've ever used Git for your code, you're going to get DVC instantly. It's basically Git for data.
It lets you track all the changes to your datasets over time. It creates this verifiable history, kind of like a data time machine, that lets you go back to any point and grab the exact data that was used for any specific model training run.
So why is this such a big deal? Well, it comes down to 4 key things. First, reproducibility. You can rerun a training from 6 months ago for an audit and get the exact same result. Second, debugging. If your model performance suddenly tanks, you can pinpoint the exact data version that caused the problem. Third, auditing. You can prove your data lineage to regulators, no questions asked. And finally, rollback. If a new batch of data comes in and it's totally corrupted, you can instantly revert back to a previous good version. It's a lifesaver.
So how is DVC any different from just using Git for everything? Well, as you can see, Git is fantastic for text-based code, but it absolutely chokes on big data files. DVC solves this problem brilliantly. It doesn't actually store the huge data files in your Git repo. Instead, it creates this tiny little metadata file, a pointer, that you do commit to Git. And that pointer just points to where the actual data lives, usually in cheap cloud storage like Azure Blob Storage. And honestly, getting started is so simple. It's just this one command, DVC add, and then the name of your data file. That's it. DVC creates a unique fingerprint of the data, makes that little pointer file, and just locks in the state of your dataset at that exact moment in time.
Now, this is where we close the loop. This is the real MLOps magic. First, DVC versions the raw data, which gives us our snapshot in time. Then, when we run a training experiment, another tool called MLflow logs the unique Git commit hash that points to that specific DVC data version. And what's the result? You get a complete, totally auditable lineage, an unbreakable chain that links the exact raw data all the way to the final model. Now, you might be thinking, hey, doesn't storing every single version of my data get super expensive? And that's a great question. This is where you have to be smart with your cloud architecture. ShopSmart uses Azure's automated lifecycle policies. So, data from the last 30 days that you might need often, it stays in hot storage. After that, it automatically gets moved to cheaper, cool storage. And after 90 days, it moves to ultra-cheap archive storage. This makes this kind of comprehensive versioning incredibly cost-effective. Okay, so we've been deep in the technical weeds. Let's pull back up now and look at the real-world impact. How did all this tech actually transform the business from that state of chaos to one of control? I mean, the before and after picture here is just, it's night and day. The data process went from manual and error-prone to fully automated. That analyst time spent on pure drudgery, it dropped to 0. Data quality went from a complete unknown to a guaranteed asset, and reproducibility went from being literally impossible to 100% achievable. And this isn't just about making engineers happy. That 40 hours of manual work they eliminated every month, that translates directly into $20,000 a year in savings, and that's just in analyst time alone. This foundational work basically paid for itself almost right away. Which really brings us to our final thought for today. In the modern world of MLOps, having a pipeline that just moves data from point A to point B, well, that's just not good enough anymore. So I'm going to leave you with this question to think about for your own projects. If your data pipeline isn't versioned and isn't reproducible, and you can't trace every single prediction back to its source, is it really ready for production?